Hey guys, this is your next topic, equations reducible to quadratics. This is your first question. It's not really a reduction, but it's getting you used to the idea of substitution. We can see in this equation that it looks very similar to a quadratic already. It's got a squared here, then a linear term, and then a constant. The only thing is, it's not x squared, it's something else. And it's not x, it's a little bit different. So what we're going to do is, we're going to replace all those things that are a little bit different with something that's a bit more familiar to us. So let u equal x plus 1. Then everywhere I see an x plus 1, I'm going to replace with u, because u and x plus 1 are equal. The equation then becomes u squared, because I've replaced the x plus 1 with u, minus 5u, once again replacing the x plus 1 with u, plus 6 equals 0. And this here is a quadratic like I'm used to. I need two numbers that multiply to give 6 and add to give -5. I know them, that's -3 and -2. So it's u minus 3, u minus 2 equals 0. From here, I solve for u normally. So this one gives me 2, whoops, this one gives me 2, and this one gives me 3. So u equals 2, or u equals 3. But u wasn't my original question. I was asked to find x. I know that u is equal to x plus 1, so I'm going to replace my u's with x plus 1. So x plus 1 equals 2, or x plus 1 equals 3. I can then find x. X is equal to 1, or x is equal to 2. And I'm done. The next type of question is an actual reduction. So let's have a look. We can see here we've got a power of 4 and we've got a power of 2. That's not quite a quadratic, but if we write this as x squared to the power of 2, now remember when we use our indice laws, that power becomes 4. So that's still true. Minus 29x squared plus 100 equals 0. We now see that it looks very similar to the quadratics that we're used to. I have something to the power of 2, and then I have that term by itself, and then I have a constant on the end. So if I use my substitution to replace these x squareds with the linear term, it'll become a quadratic. So I let u equal x squared. Now everywhere I see an x squared, I'm going to replace with a u. That becomes u squared, not u to the power of 4, just u squared, because I've replaced the x squared with u. Minus 29u plus 100 equals 0. When I factorize this, I get u minus 25 and u minus 4 equals 0. This gives me the solution 25 and the solution 4. Therefore, u equals 25 or u equals 4. But u wasn't what I was asked to find. Remember that u is equal to x squared. That means that x squared equals 25 or x squared equals 4. If I take the square root of both sides, I find that x is equal to plus or minus the square root of 5, or x is equal to, whoops, it's not right, plus or minus the square root of 25, or x is equal to plus or minus the square root of 4, and the square root of 25 is 5, so x is equal to plus or minus 5, or plus or minus 2. So you get your 4 answers for your quadratic. Okay, fix the question. I'm going to have a look at this term here. I need that to the power of 2. So what I can do is I can switch these two around. And I can do that because 5 squared to the power of x is just 5 to the power of 2x, which I can also write as this. Okay? Now remember, using our indice laws, this is 2x, this is 2x, this is also 2x. So if I write it any of these ways, it is true. So I replace this term, or not replace, rewrite it like this. And I've now got a quadratic equation, or something that can be reduced to a quadratic equation, because I've got a term squared, then it by itself, and then a constant term at the end over here. So I use my substitution, and I say let u equal 5 to the power of x. So everywhere I see 5 to the power of x, I replace that with a u. This becomes, oops, here we go, u squared minus 124u minus 125. Okay, that's just replacing all the 5 to the power of x's with u's. I then factorize, and my two numbers are minus 125 and plus 1, so that's u minus 125, and u plus 1 is equal to 0. I solve that and I get u equals 125, or u is equal to minus 1. But if you recall, u is just 5 to the power of x. So 5 to the power of x equals 125, or 5 to the power of x equals minus 1. When I look at the left-hand equation, I have 5 to the power of x equals 5 to the power of 3, therefore x equals 3. Just equating the indices like we've done previously. If I look at the right-hand equation, I actually don't have any solutions because when I look at an exponential curve, it looks like this, but minus 1 is down here somewhere. This curve never actually goes down that far. In fact, there's an asymptote at y equals 0. This means that there are no solutions. In other words, there is no power of x that I can use to give this a negative answer. Therefore, there's no solutions over here. And there's only one answer, and you're done. They are the 3 types of questions you guys will be getting on this topic.